I am confident that by 2040, no one will think about putting traditional gray concrete in the water, knowing what it does.
How do we make marine infrastructure green? It's a really important issue in coastal communities around the world. It is a really important issue here in Miami. To dig into this issue, we're joined by Michal Judovits, Chief Commercial Officer for ECOncrete. Michal, thanks so much for joining us.
Hi, man. Thank you so much. Happy to be here.
Thank you. And thank you for taking the time from Tel Aviv to join us here in Miami. We really appreciate it. So let's start with just the basics, the fundamentals of what ECOncrete is.
What we're doing is ecological concrete for coastal and marine construction. Everything is completely in line with the construction standards. So we're taking the traditional gray concrete and making it green or blue, depends what you're asking, by changing three elements. One is the composition, the chemical composition of the concrete. Two is the surface, and three is the macro design. What we're doing is actually to allow biology to exist in the water, to exist on the infrastructure as it was before construction. So that's the very simplified way of what we're doing.
What's an example of where ECOncrete is deploying this concrete technology?
So as I'm saying, it is a technology because everything is local labor and local materials. And what we're doing is either to implement the technology into existing construction. So if there is a seawall, if there is a coastal protection, if there is a breakwater, ports, marinas, bridges, tunnels, any concrete that is below the mean height tide, then we are putting our technology into that concrete, making it more environmental friendly in that way. The other option is implementation of our own product that has been designed as a requirement for different projects. So either putting the technology into existing designs or using very unique products. But what we're doing is just to allow solutions for any concrete that is being put in the water.
Give us a sense of how big this market is. I mean, when you say it's, breakwaters, seawalls, ports, it feels enormous.
We're talking about hundreds of billions of getting to the trillions market if you're talking about constructions in the water. You have infrastructure that is being done on the marine side. So it is close to shore, on the shore, and also offshore. So the solutions for all of the oil and gas industry, as well as the wind farms that are being constructed more and more, especially on the east side. The size of the market is enormous because this is potentially all the construction. Eventually, when we're trying to narrow it down, then we're talking about 70% of all coastal and marine constructions are concrete-based.
What's specifically sort of the problem that you're solving with ECOncrete? In particular, what is it about that traditional concrete that burdens the marine ecosystem?
So what happened is that when you're putting traditional concrete in the water, there are chemicals in the concrete that are being added to any modern-like concrete, and those chemicals are leaching to the water. What we're doing is just to prevent, by this admix that we're adding to the concrete, we're preventing those chemicals from leaching to the water. So biology that was there before can still exist in the water, and we're neutralizing the surface of the concrete. So by neutralizing that, we're allowing settlement. But then when we're thinking about concrete, we're thinking about something that is very straight, very smooth. And what we're doing is to create this micro design, those micro holes that if you're touching the concrete, it mimics a texture of a natural rock. So you have this feeling that of touching, but that allows juvenile larvae to settle on the concrete. And then the third phase is to allow survival. Then we're actually supporting the local species, because I keep on having discussions with people that are saying anything you're going to put in the water is going to have some biology on that eventually, which is true. But the question is which type of biology? How diverse is that? We keep on hearing this buzzword that became to be biodiversity. What it actually means is to make sure that you have variety of species and not just one. But those species are the local species instead of invasive species. But if we don't create this favorable environment for the local species that are less durable, less survivals, then eventually over time they're getting pushed from their natural environment.
What is sort of the special sauce? I mean, what is the concrete made of that allows for it? I mean, you talked about texture and how moving away from the smooth surfaces we typically see of seawalls, but actually the material that is put together so that it can so mimic the natural environment.
What we're adding is an admix that is 10% of the cementitious component in the concrete. So what it does, as I was saying, this is byproduct of the industry, so it doesn't add more emissions. But what it does is to capsulate chemicals from leaching back to the water and neutralizing the surface. So this is the admix that is being added. That's what changed the chemical composition of the concrete. So structural wise, it is performing at least as good. Most will say that probably stronger and more durable over time. But the environmental impact of not having chemicals that are leaching from the concrete, that's the secret sauce.
You know, so often in doing things that are more sustainable, more environmental friendly, at the outset at least, it's more expensive. What is in terms of doing this type of concrete versus traditional concrete, what is the difference in terms of cost?
I love this question. That's one of my favorite questions. On a project level, by building in a responsible way, it allows you to facilitate permitting, so shortening time. Time is money. It allows you reduction of mitigation cost. It allows you reduction of maintenance cost over time. So all those things, when you're putting together a business case and when you're putting together an infrastructure, knowing that it needs to be there for a design for 50 years or 70 years, or if we're talking about offshore, we're talking about 25 to 30 years, then you care about what's happening in 15 or 20 years when you need to put more money into maintenance. You care about what's happening in decommissioning day. And on that, we actually managing to show a better ROI compared to traditional concrete.
Give us some context of when this idea was hatched, launched, and sort of how long sort of ECOncrete has been in the business of sustainable concrete.
So the company has been established 11 years ago by two PhD of marine biologists. They started the company with the envision of changing the way that the future coastline is going to look like. With time, we moved from shore also to the offshore, but it started really due to the fact that they were spending so much time diving and looking at infrastructure and realizing how putting concrete in the water is so harmful. And by seeing all of that, they were really searching for something to do differently. In one of those days, as they were diving, they saw that on the same pile that has been casted in different sections, then there was a different settlement on the concrete. And after spending some time under the water, they went out and they were asking, how could it be? What's different? Has it been casted on different days? Has it been different materials? Is it not the same concrete that has been used? And they start asking questions, realizing that there is something to do that will allow more embryology to settle on that. We have products in the water for over a decade now, but the first installation was done in the Brooklyn Bridge Park. So in New York, that was the first time that we start putting products in the water. And we have different products, tide pools and pile jackets that are still in the Brooklyn Bridge Park until this very day, keep on being monitored.
Where are some of the places right now that this technology is being utilized? What are some of the ports or projects that you can tell us about?
So we have more than 40 installations in 13 different countries, 9 different seas. US counting as one country, but we have ECOncrete in the water in 5 different states, in New York, in New Jersey, in Florida, in Washington State, and in California. We have installations for coastal protection. We have installations for working waterfront. We have installations for offshore. And New Zealand is the latest flag that we put in the water.
Wow. So if you were to give us, say, 3 examples of projects right now, what would be, 3 examples that come to mind?
One project that we're extremely proud of is the Living Breakwater project. So this is in Staten Island in New York. It's still under construction, and construction is expected to be completed by the end of 2024. We're talking about 8 full-scale breakwater in order to protect the tip of the island, federal budgeted project after Hurricane Sandy. And our technology has been incorporated into the breakwaters. We have tide pools, we have armor blocks. And one of the things I like best about this project is that we have collaborations with the Billion Oyster Project, that we have oyster disc where oysters are settling on the concrete units after proving that there is a better settlement than natural rock on the concrete units themselves. So working together with an NGO in order to promote other causes, other agendas. So this is one project that we're extremely proud of. We are involved in protections of cables and pipes for the new wind farms on the northeast. So that is another thing that we're very happy with. And actually, as a third project, it's not a big project, but it's a very exciting project. In Fuerteventura, Canary Island, Spain, the national electricity company needed to pass a cable between 2 different islands, and the whole area is a nature reserved area. So it's very, very environmental sensitivity to put anything there. And our technology that has been recognized as sensitive enough to be put there has been installed. Marine mattresses are covering this cable. If you're diving there, you don't see a cable at all. It completely vanished, disappeared, and the seabed completely recovered itself after less than a year from installation, to the level that there is zero environmental effect from putting a large electricity cable between 2 islands. So it's quite exciting.
What are the ways that you can imagine that sustainable concrete and ECOncrete, specifically the work that you're doing, your company, doing work here in Miami?
Well, focusing on Miami, I think that the 2 big things that I can name, one is the ports. So the port itself, Miami Port, and talking about marinas along the coastline, there is ongoing construction. As I was saying, it's not just when you're building a new infrastructure, there is also the maintenance, more and more concrete that is being added to the water. I think this is one that is relevant. And then with sea level rise, more and more seawalls are being built, and they're higher, they're stronger, they're deeper. And I think that is very, very relevant, knowing that over time, with the climate risk and very accelerated process of that, there is going to be an additional need. Then I think that while planning seawalls that are not going to harm the environment, on the other hand, also thinking about the communities, allowing educational tours to come and see what is growing on that, involving the local communities as we have in different locations, supporting the local fisheries because we have more biology that is in the water.
We always like to talk about sort of the future, right? In particular, we're thinking about sort of the Miami or the world of 2040, particularly as you think around marine infrastructure and the work that you're trying to do. What do you hope that world looks like?
Wow, great one. So I will say 2 things. One is that with the sea level rise, with current climate being more and more extreme, we're going to see more and more concrete being put at sea. We're going to see higher walls, we're going to see more revetment, we're going to see more concrete being added to the water. If you ask me what do I envision for 2040, is for every concrete in the water to be ecological. I am confident that by 2040, no one will think about putting traditional gray concrete in the water, knowing what it does.
Michal Judovits, thank you very much for the time. We really appreciate it.
Thank you. It was a pleasure.